Hi, Dahlia Remler here again. So now we're into the last chapter that I'm going to cover on natural and quasi experiments. And really these are a whole bundle of different types of approaches to causal research, to estimating a causal effect. And they're situated in the middle of observational studies where the independent variable just does what it does in the world, being driven by the dependent variable, by other things that drive the dependent variable. And we have to try and do our best to disentangle its effect without having any kind of big push on that independent variable to give us information. That's what we had at one extreme. On the other extreme, we had the randomized experiments where the all-powerful researcher just flips a coin or in some random way says, you treatment, you control, and we can beautifully observe the effect. Never mind all those human artifacts, generalizability, other problems, not to mention ethics in many cases. So now this is a large group of types of studies in the middle, and they kind of range in their internal validity, in the quality of the causal evidence. So the example that we had in the opening book was about mental health and poverty. So for years and years, there's been endless studies showing that poorer people have worse mental health on average. As you recognize by now, a correlation, bringing about the obvious question, well, if we reduced poverty, would mental health improve? A causal question, but hard to answer. So there are a bunch of researchers which found themselves in this lucky position. They were already running a study on a Cherokee reservation and its surrounding areas with Cherokee and non-Cherokee families in the surrounding areas. It was a longitudinal study focused on children, and it was following the children over time already. But it was descriptive, and it wasn't, expecting any kind of experimental changes. Then the Cherokee group there decided to build a casino to raise income for all the tribe members. So they did that, and all the members got checks raising the income of all the families. You got a check, no matter about the mental health of the parents or the children, no matter how much they earned, their education, none of that. Just everyone got a check. So it was exogenous. It was an exogenous push on poverty, decreasing poverty. This is a natural experiment. A casino isn't natural in like a hurricane or genetics or anything like that. They built the casino, but it was just kind of luck that happened to do that. So what are natural and quasi experiments? The idea is that there's a treatment, a program, an independent variable that is exogenous to the outcome, the dependent variable, or at least reasonably close. So remember, that's like that push we get on the independent variable, enabling us to see what happens to the outcome. And it is not randomized by the researcher the way it is in a randomized experiment. They come in many, many forms. So a natural experiment is just kind of taking advantage of some exogenous event that happens. Through, there's exogeneity, there's this push on the independent variable kind of from outside the system of stuff that drives the dependent variable. It occurs through some naturally occurring or unplanned event that happens to be exogenous to the outcome. And that enables us to make comparisons over time or to those between the treatment and without the treatment. The idea is the groups can be otherwise comparable. And we can see how the outcomes differ, right? Because that's key to estimating the effect on the outcome. We have to have the outcome with the treatment, outcome without the treatment. And the term natural experiment actually comes from economics, where, there are lots of things people wanted to know the effect of, and traditionally you couldn't do economics. We will not be randomizing people to capitalistic and socialistic economies to see what happens. So a lot of things like that drove the interest in natural experiments. The idea of quasi-experiments is not really sort of a counterpart to the natural experiment, but a kind of a different dimension. The idea there arose in psychology research, and it's the idea is that you have a treatment, it's manipulated in order to affect the outcome. And originally the idea was manipulated by researchers, but they can't randomize people. So instead they have a comparison group. So you can think of that as like a control group, but not quite as good. Those who do not get the treatment. And again, you compare treatment and comparison groups, but they're not randomly assigned. There was also the idea that administrators and program managers could be part of the experimenting society. And so it became not just researchers conducting quasi-experiments, but quasi-experiments that kind of come out of administrative things. So you can kind of see sometimes natural and quasi-experiments blend. So the main quasi-experiment example we used in the book is the effect of resident management in public housing on quality of life. So what happened is that selected public housing complex received this program, the resident management program. Somehow that was decided. The researchers didn't control which ones did, the funders did. And basically a bunch of researchers were brought in to try to find comparable public housing to have a comparison group. So now, as we go through this, I want you to try and think of a program you want to evaluate, something you already work with, something you would like to propose, something you've heard about, something you're interested in. Think of a program and one outcome. For the moment, just one outcome. And what you're going to do, a little bit right now, but more as we go through all of these slides, is try to design a quasi-experiment to evaluate the program's effect on the outcome. So what I mean by that is you will be able to control, to some extent, who gets the program and who doesn't, when they get the program and when they don't. But I also want you to do something realistic that you could do in the real world. So pause the video for a moment, think about your program, think about your outcome, maybe think a teeny bit about the quasi-experiment, especially if you've read the chapter. Okay, so I've already talked a little bit about quasi versus natural experiments. So a natural experiment is like finding a comparison. The independent variable is not manipulated by the researcher to affect the outcome, but the casinos were created, but not to improve mental health. Quasi-experiment is kind of creating the comparisons. The independent variable is manipulated to affect the outcome. It's not a perfect distinction. They're really different dimensions, really. And actually, Greg Van Ryzin and I are working on a better taxonomy, a richer one, because the terms are not really used consistently. Nonetheless, we think that this distinction is important even though other people don't make it, and they're really different dimensions. Why? Because the emphasis on creating exogeneity and comparability encourages program planners to find ways to create strong experiments. So all you practitioners out there, look for opportunities to get good evidence about the effectiveness of your program. You can provide the treatment to some, but not all. Random assignment, that would be a randomized experiment. It's fair for limited resources, or maybe there's something that falls short of random but can help you do that. Randomly assign the program to whole groups, to clusters, and especially, I'm going to emphasize this last one a lot, control the timing of rollout. So a great way to do this is with the diff and diff study we're going to get to, and I always tell my students that's a great way, a diff and diff, for you, a realistic way and a way that a lot of people don't understand to get good evidence. For that, you need to control the timing of the rollout, give it to some groups before others, and we'll talk about how you choose those groups, and also be gathering outcomes before program implementation, right? All that performance management, always be gathering your outcomes all the time and in a consistent way. So that's my big pitch to the practitioners, most of my students. Also, this distinction emphasizes finding exogeneity and comparability, which encourages researchers to look for natural experiments. In grad school, my professors told me, always have your eye out for looking for natural experiments that can help you answer these causal questions. So again, these are a whole collection of different methods, and in specific instances, they vary in how good they are. And it's not so much the type of study, quasi-experiment that's pre-post is a really good study. A natural diff and diff is a good study. Diff and diff is a good study, but as we'll see, it all depends, right? It all depends on the particularities in the particular instances. So you have to look at the specifics, and you need to kind of do your due diligence, qualitative research, talking to people, investigating other evidence. What are you looking for? Exogeneity of treatment assignment. Treatment assignment means who gets the treatment, who doesn't. Or maybe it's a variety of treatments. Maybe it's a whole bunch of there's a quantitative variable that's the independent variable, but how does it happen that some people get one independent value and other people get another value? Do they live in different places? Does a researcher control that? How does that happen? Also, related but not the same thing, comparability of treatment and comparison groups. Again, the different values of the independent variable, the people who have them. They should be comparable in all the ways that are relevant to the dependent variable. But it's okay if they're not comparable in ways that aren't relevant to the dependent variable. So I just said one way treatment assignment may occur is by where people live. Which state do they live in with different rules or different laws or different programs? If the people in the different states are comparable in ways relevant to the dependent variable, states are good way to assign treatment. But all of these things cannot guarantee full exogeneity and comparability. So they're always lower in internal validity than true randomized experiments. So again, how are you going to judge the comparability? You're going to check your groups, your different groups, or your before and after features for everything you've measured, but that is not enough. This is not a randomized experiment. There are no guarantees on unmeasured variables. So you need to theorize about how much the unmeasured variables might differ. And like in the observational studies, the key is what affects the outcome, and what especially what drives the independent variable. Why do some people get the treatment and not others? You know, political favoritism. Does that matter? And the key you want is as close as possible to the independent variable being exogenous to the dependent variable, meaning no reverse causation, no common causes. So in our quasi-experimental example, we want to start with why did the projects with resident management get to be in the program? Was this a more activist resident management group in those public housing complexes? Were they like working on, you know, great community rooms and public safety and cleaning everything up? Were they doing a great job anyway? And they're like, oh, resident management, we want that. Or was this a particularly well-connected politically public housing project? So you're looking for why they got it and whether those factors differed in comparison groups, or was it just kind of random? Well, it was in this this congressman's jurisdiction, sorry, or this state senator's jurisdiction, but that had no other effects. So remember, some differences between groups are not relevant to the outcome. So if we're looking at quality of life, like safety and service and cleanliness of the different public housing projects, what are some differences that are not relevant to the outcome? You know, so I often say, you know, green paint versus blue paint on the walls, although I don't know. Maybe green versus blue does have an effect I don't know about. So take a moment, try and think of things that don't matter. And maybe, like me and my paint color, you'll find things that, well, maybe they matter, but they're not going to be really big. Because nothing's perfect. Few real-world quasi or natural experiments have perfect exogeneity and comparability. So if the groups aren't comparable, you're looking to see whether they're not comparable to an important degree in ways relevant to the outcome. And if so, you're not going to get internal validity, not going to provide a good, convincing estimate of the causal effect of treatment. So take a second, think about that resident management in public housing, and thinking about some difference between the groups that got the resident management, the groups that didn't, what things might not be perfect. So we also need to think about the generalizability of natural and quasi-experiments. Again, also called external validity, like with the other causal studies. And it's often better than randomized experiments, right? We talked about how expensive and difficult those are to do, the very unusual circumstances, and the many ways that randomized experiments are often not generalizable, because natural and quasi-experiments are often occurring much more in the everyday real world. Their generalizability is often better, just like often, not always, their internal validity is worse. How do you judge generalizability? Well, first, two keys are exactly the same as they were with observational studies and randomized experiments. First, look at the broader population, the setting, so on. Where was it done? Second, look at your actual study subjects and how representative they are of the broader population where you're doing the study. The more representative, the better the evidence. Then, the next thing, though, is a little different, especially for randomized experiments, because in effect, you're kind of randomizing a subset of people, often in a natural experiment. Not everyone. Not everyone in your data. We'll talk a little more about that. The jargon for this is local average treatment effect, or LATE. You don't need to know the jargon in my class, but the idea is important. So for natural experiments in particular, there are these subtleties that only those who got randomized are you really learning about. The last part of judging generalizability, again, is like it was for the other studies. Once you've sort of figured out your population that the study told you about, then you have to think about generalizability to different populations, maybe even quite different populations. And that's kind of an art, that requires a lot of outside knowledge and shoe leather. Remember that shoe leather thing? To investigate things qualitatively, talking to people, things. You're just trying to figure out, what's an important variable. And the key for making that judgment is the mechanism of the treatment, right? Because what variables is this program or treatment really changing? If you have a tutoring program, then maybe the most important issue of the population is how far behind they are academically and how not useful the regular classroom is. So you really have to think a lot, and it's more of an art. But again, part isn't specific to natural and quasi experiments. That's the same for all our causal studies. Okay, so that's it for the general approach to natural and quasi experiments, what the words mean, how they're similar, how they're different, and the big picture for judging their internal validity or the quality of the causal evidence, meaning if you do this study and you get a result, how convincing is the result? How much do you actually believe it's a causal effect that you've estimated? And also the big picture of judging the generalizability of natural and quasi experiments. Next video, we're going to turn to all the different forms of quasi and natural experiments.